Hi, I'm trying to build a submarine and I need to make this tube watertight. So how many attempts do you think it took me to achieve this? Let's find out. I'm using O-rings and I know at least two ways of how they could be used for sealing. First, you use a ring that matches the face of the cylinder and then you put it between the end cap and the cylinder. Second, you can use an internal ring, and so you make a groove on the inner part of the end cap and put the ring inside it. This really works and looks like a piston. By the way, if you know how these two methods are actually called, or if you know more, please tell me in the comments down below. Since I didn't know which one would work first and how many attempts each method would take, I decided to order both types of O-ring. So what do you think, which one I managed to make work first? Well, I was absolutely sure that the face one would work from the first attempt, because what possibly could go wrong, right? You don't have any complex grooves to design. And if you have a flat surface on the cap and on the cylinder, I mean, that's easy, right? This should work. Well, no. The issue is that the 3-point end cap with 15% infill is not holding its shape properly when bolted together. So you can see it's curved and it has quite good seal near the bolts, but in the middle it's where it's always leaking. Actually, Murphy's Law played a trick with me today. I couldn't reproduce the leaking, so this is a leak, but it's on the side and I probably over-tightened the bolts because I wasn't really caring about the deformation. I guess if you don't care about bending your parts, you could theoretically still make the 3-point end cap work, but I wouldn't recommend this. You probably wonder, if this is a submarine, I probably should have been testing the inability of water to get from outside to the inside instead of the other way around, right? Well, yes, you're right, and I'm dumb. End of the video. It turns out that there are two reasons to do this. One, it's easier to test, and the second one is that if it works for the solution when the water is inside, then it should theoretically work even better for the other way around scenario, because the water pressure would press the end cap to the cylinder with more force, and ideally this should make the seal tighter. I increased infill to 30% instead of 15%. I sanded the face of my cylinder as much as I could, but it still leaked. I mean, there was some visible progress, or at least I want to believe there is some, but in any case I decided to put this aside and to switch to the inner ring solution. I had to model this groove and it took of course several attempts, but the cool thing about this solution was that one can actually predict if it's going to work or not even before pouring water inside. When the rubber is pressed against the acrylic, it changes color, and by the width of this contact zone you could actually understand how consistent and strong your seal is going to be. If it's thin or absent, then it's a good sign that it's actually not going to work at all. And here it is. It holds almost 30 centimeters of water, and it can hold it indefinitely long. But although this solution was way faster, I wasn't sure if it's going to be very reliable in the long run. So I decided to switch back to the face ring option, and the obvious solution would be to increase the number of contact points. And why this is important? Well, first, this decreases the distance between adjacent bolts, and the cap won't be able to deform as much at a shorter distance. Second, we bring the lines that constitute our holding triangle closer to the O-ring. When we tighten the bolts, a couple of breaking points appear at the intersection of the O-ring and the side of the triangle, and everything between these breaking points tends to move upwards instead of being pressed against the O-ring. So reducing the braking zone should help a lot. I decided to play it safe and skip the square arrangement, and so I stepped it up from a triangle directly to a pentagon shape. And it worked. It finally was able to hold water. Probably I could have achieved the same by making the triangle larger, but this kind of contradicted with the existing design of the submarine, so increasing the number of bolting points was more preferable. And it finally worked. Almost 30 centimeters of water successfully contained. So I ended up with the knowledge on how to build both types of seals for my submarine project. But in the end of the day, I decided to stick only to a face seal. And the reason behind this is that I can't imagine a scenario when this seal fails, but this type of seal holds. But I have an idea how an end cap with both type of seals can actually bring a very cool feature to the table. So I'll try to test this and to cover this in one of the future videos. So stay tuned.